Projective Geometry, Volume 1, by Oswald, Veblen, and John Wesley Young.
Chapter 10, Projective Transformations of Two-Dimensional Forms. Section 94, Analytic Representation of a Correlation between Two Planes, Bilinear Forms. Let a system of simultaneous point and line coordinates be established in a planar field. We then have Theorem 5. Any correlation in a plane is given as a transformation of points into lines by equations of the form, equations 1. Rho u1 prime equals a11x1 plus a12x2 plus a13x3. Rho u2 prime equals a21x1 plus a22x2 plus a23x3. Rho u3 prime equals a31x1 plus a32x2 plus a33x3, where the determinant A of the coefficients A sub ij is different from 0. Conversely, every transformation of this form in which the determinant A is different from 0 represents a correlation. The proof of this theorem is completely analogous to the proof of Theorem 8, Chapter 7, and need not be repeated here. As a corollary, we have Corollary 1. The transformation rho u1 prime equals x1, rho u2 prime equals x2, rho u3 prime equals x3 in a plane represents a polarity in which to every side of the triangle of reference corresponds the opposite vertex. Also, if u1 prime, u2 prime, u3 prime be interpreted as line coordinates in a plane different from that containing the points x1, x2, x3, and if the number systems are so related that the correspondence x prime equal x between the two planes is projective, we have at once Corollary 2. The equations of Theorem 5 also represent a correlation between the plane of x1, x2, x3 and the plane of u1 prime, u2 prime, u3 prime. Returning now to the consideration of a correlation in a plane, planar field, we have seen that the equations 1 give the coordinates u1 prime, u2 prime, u3 prime of the line u prime equal gamma of x, which corresponds to the point x equal x1, x2, x3. By solving these equations for x sub I, equations 2, sigma x1 equals a11 u1 prime plus a21 u2 prime plus a31 u3 prime. Sigma x2 equals a12 u1 prime plus a22 u2 prime plus a32 u3 prime. Sigma x3 equals a13 u1 prime plus a23 u2 prime plus a33 u3 prime. We obtain the coordinates of x equal gamma inverse of u prime in terms of the coordinates u sub I prime of the line to which x is homologous in the inverse correlation gamma inverse. If, however, we seek the coordinates of the point x prime equal gamma of u, which corresponds to any line u in the correlation gamma, we may proceed as follows. Let the equation of the point x prime equal x1 prime, x2 prime, x3 prime in line coordinates be u1 prime, x1 prime plus u2 prime, x2 prime plus u3 prime, x3 prime equals 0. Substituting in this equation from equations 1 and arranging the terms as a linear expression in x1, x2, x3. u1 x1 plus u2 x2 plus u3 x3 equals 0. We readily find equations 3, tau u1 equals a11 x1 prime plus a21 x2 prime plus a31 x3 prime. Tau u2 equals a12 x1 prime plus a22 x2 prime plus a32 x3 prime. Tau u3 equals a13 x1 prime plus a23 x2 prime plus a33 x3 prime. The coordinates of x prime in terms of the coordinates of u are then given by equations 4, Nu x1 prime equals a11u1 plus a12u2 plus a13u3. Nu x2 prime equals a21u1 plus a22u2 plus a23u3. Nu x3 prime equals a31u1 plus a32u2 plus a33u3. This is the analytic expression of the correlation as a transformation of lines into points, i.e., of the induced correlation of gamma. These equations clearly apply also in the case of a correlation between two different planes. It is perhaps well to emphasize the fact that equation 1 expresses gamma as a transformation of points into lines, while equation 4 represents the induced correlation of lines into points. Since we consider a correlation as a transformation of points into lines and lines into points, gamma is completely represented by equations 1 and equations 4 taken together. Equations 2 and 3 taken together represent the inverse of gamma. Another way of representing gamma analytically is obtained by observing that the point x1, x2, x3 is transformed by gamma into the line whose equation in current coordinates x1 prime, x2 prime, x3 prime is u1 prime x1 prime plus u2 prime x2 prime plus u3 prime x3 prime equals 0, or equation 5. The quantity a11x1 plus a12x2 plus a13x3 close paren times x1 prime plus the quantity a21x1 plus a22x2 plus a23x3 close times x2 prime plus the quantity a31x1 plus a32x2 plus a33x3 close times x3 prime equals 0. The left-hand member of equation 5 is a general ternary bilinear form. We have then Corollary 3. Any ternary bilinear form in which the determinant A is different from 0 represents a correlation in a plane.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renhold, with programming and illustration by Jim Renhold, 2019. Thank you for listening.